Welcome to the third and last example of today's notes. And we're going to talk about using Lagrange multipliers to find the max and min values of the function subject to the given constraint. And this one's going to be a little bit more difficult, and it's going to involve some logic. So I'm never going to really test you on this one, but I am going to give you another homework problem on this because I do want you to try to understand it. But I can see how it can be a little difficult. So again, I want you, please, I hope you're doing the homework just to go ahead and so that you have a better understanding and you get more out of the class if you do the homework. For like an assignment, I'm never going to give you this as an assignment problem or like a test problem. I'm going to give you more like the previous two. So now, let's go ahead and look at this. Use Lagrange multipliers to find the max and min values of the function subject to the given constraint. All right, so again, I'm going to go take the partial of f. Not partial, but the gradient of f, which is the partial with x, y, and z. So again, here we have, a function in 4D, which is already kind of crazy. So when we take the gradient of f, we're going to get x to the fourth plus y to the fourth plus z to the fourth. We're going to get the vector 4x cubed. That is not a cube. 4y cubed and 4z cubed. And then if we do, again, g is just x squared plus y squared plus z squared equals g of x of y of z and z. So our gradient of g, I'm going to go ahead and just do the gradient of g. The gradient of g is going to give us 2x, 2y, 2z. And again, using Lagrange multipliers, there's going to be a lambda. And so this is going to equal, and then I'm going to put my lambda on the outside. Now, let's go ahead and set the components equal to one another. And there's going to be some cases where we're going to actually have to take. So 4x cubed is going to be equal to 2 lambda x. We have the case for y cubed is going to be equal to 2 lambda y. And then we also have the case for z cubed is going to equal 2 lambda z. Now, looking at all of these, all right, let's focus on the first one. 4x cubed equals 2 lambda x. All right, and looking at this, there's pretty much two possible values. Either we can solve this for lambda, which I'm going to do. I'm going to solve all these for lambda, or we can say, hey, x would be 0 because then this solution would hold. If x equals 0, that solution holds. All right, or y could equal 0, and then that equation holds, or z is equal to 0, and that solution holds. The one thing that cannot happen is that all three of these equal 0, all right, because of our constraint. If all those equal 0, then x squared plus y squared plus z squared could not equal 1. So we have a few cases to take, and the first case is going to be case 1. Put the 1 after. Case 1. Case 1 is, okay, none of those equal 0. All right, so we're actually going to have the value for lambda. So if, none of our variables equal 0, so x does not equal 0, y does not equal 0, and z does not equal 0, then what we can say is that lambda is going to equal, if I solve for lambda, I divide that by 2x, and I get 2x squared. If I solve for lambda there, I would divide both sides by 2y and get 2y squared. And if I divided 2z to that equation, I get 2z squared. And again, we can pull out the z, or the 2, because they all equal each other, so let's just get rid of the 2. So then we could say, or x squared equals y squared equals z squared. All right, now if x squared equals y squared equals z squared, and we plug that into our original, We could, we could plug all those in for x squared plus x squared plus x squared equals 1. We'd get 3x squared. And, I'll just plug it in. You don't have to plug it in. Hopefully you see it. But if I plug in, okay, so if all of those equal x squared, I could say x squared. Let me use a different color to show it as well. So I could say x squared plus x squared. Again, this is going to be, that's y. And then plus z squared, which we're saying that's going to be equal to x squared. Base everything off of there. That's equal to 1. Or we could say 3x squared is equal to 1. And then we could say, well, hey, I solved for that. And what I'm going to be able to get is x is equal to plus or minus, or I'll just say x squared is equal to 1/3. We don't have to solve for that. All right, so x squared is equal to 1/3. Right? Or we could say x is equal to plus or minus, 1 over radical 3. All right, but we can just say x squared is equal to 1/3. Well, if x squared is equal to 1/3, that means also y squared is equal to 1/3 and z squared is equal to 1/3. And if we actually, solve all this out, it's going to give us 8 points. And they're all going to equal the same value. So if x squared equals 1/3, y squared equals 1/3, and z squared equals 1/3, and it's, plus or minus, what we can do is when we actually plug it into our function, all right, we're going to get really 1/3 squared plus 1/3 squared plus 1/3 squared. That's going to give us 3 over 9, which is going to give us 1/3. So when we plug in all those 8 points, our f value is going to always equal 1/3, given this case. All right, so if x and y and z did not equal 0, we're just all going to get our f value, the greatest that we're going to be able to be, or we're always going to be 1/3. So now let's look at case 2. Let's say one of those is 0. I'm in the section that I can't write. So one variable is equal to 0. So x squared equals 0, y squared, x equals 0, y equals 0, or z equals 0. We're going to make one of those equal to 0. So one variable is 0, other two are not. Then the squares of the two non-zero coordinates are equal. So then what would happen is, then what would happen would be is that, okay, if one of those is 0, and this is just one case. It could be y equals 0 or z equals 0. But I want to show you. So if x is equal to 0, then that means that y squared is still going to equal z squared. And we're still going to plug in to our function up here. So then that would mean is that, okay, we have x squared plus y squared plus z squared equals 1. Y squared equals z squared and x squared is 0. We would just have something like this. In this section I can't write. Y squared plus y squared equals not 0 but 1. So therefore 2y squared equals 1, or we could say y squared equals 1/2. That means z squared would be 1/2. So then our other two components, would have a common value of 1/2. So the corresponding f value is going to be 1/2. When we plug that in, all right, if we plugged in, I'll just show you an example of just plugging. So our f value is 1/2. So if, let's just, and this is just, again, this can be any case. It could have been, I made z equals 0. Then I had x squared and y squared would both be 1/2. So if one of the variables is 0, then the other two are going to be x squared. The other two squareds are going to be equal to 1/2. If we plug that in, so say we had x is 0. So we would have 0 to the 4th plus, I should have used blue above. I'm sorry, I was thinking I should have used blue. I'd have y squared. Oh, here, we're saying y squared is 1/2. So squared plus another z squared, but z is 1/2. So z squared squared is z to the 4th. And so we're going to get, when we do that, we get 1/4 plus 1/4, which is equal to 1/2. All right. Now, what if 2 So case 3. Again, we can't have a case 4 because they can't all be 0. But case 3, what if 2 variables are 0 and 1 is not? So say, hey, we made x equals 0 and y equals 0. That means all that's left is z squared. All right. And well, z squared, so it would be 0 squared plus 0 squared plus c squared, so it would be z squared equals 1. All right, and if z squared is 1, then, of course, that's going to be our greatest f value, because what's 1's, it would be, so our greatest, let me write that down first. Our greatest f value is equal to 1. Why? Because I'd have 0 squared plus 0 squared plus 1 squared. Because z squared, if you didn't see that, it's because z squared is equal to z to the 4th, and z squared is 1. So our greatest f value is going to be 1. All right, so we do have max and we have a min. So the max value of f is 1. So the max value of f is 1, and min value of f is going to be, what did we say it was? 1/3. All right, and that's it. Again, if you have questions, just please come to me and I can explain it in the room. And if not, I hope you all have a great day.